So, all right, let's see how this one goes. I can say this is fifth period, not second period, so hopefully second period doesn't feel bad about that. Now you ask a question after I hit start on the video. Okay, they're going to listen to it.
For like the grading for the final, are you just giving like one whole point or zero? Or
No, there'll be partial credit concept with that. And I'm not looking to be like super, demanding on it. So that's not the intent on the final. Okay, so we got to talk about mathematical addition of vectors now, which I hope you will like going here, because now whether or not you get the right answer, it's not really about can you use a protractor and a ruler, it's can you use a calculator, but do you understand how the pieces fit together? Oh, you found it. All right. He's all oxygenated and ready to go. We're playing a Santar game.
Oh.
So I was Santar this morning, so I had to go hide it. And I said that it needed a breath of fresh air because it was suffocating in here. So I put it behind the air purifier in the room next door. Okay. People are going to be watching this going, what the hell is he talking about? It's like, whatever. It's all part of the experience. Okay. So what we're going to do is we are going to do this problem graphically in a sketch form, and then we're going to try and put together some math, hopefully that you can see, so to speak, from the sketch. So we are going to add BCH to get R. So I'm just going to go ahead and start by saying if you looked at B, C, and H, and you started to think, where should I start this problem? We shouldn't start it in the middle. We should start it kind of over here, so we can use up more space. So here is what I need somebody to do first. I need you to come draw B for me. Now it's not this exact thing that you have to have a meter stick for. I just want you to direct B in the right direction and make it a given length. And put the arrow and label it. Anybody want to go for it? And others better be ready because I'm going to need volunteers here. Who's drawing B? All right, Ben. Now there's only one bit of pressure, not necessarily pressure, but you're going to set the stage for one thing.
Don't use a ruler, just freehand.
Yeah, just freehand it. And the idea is that you are going to kind of set the scale for this problem. So you just make it decently long, and then everybody else will adjust lengths according to yours. Okay? All right, and that's B. So go ahead and label that. Perfect. All right, that's all we got to do to start with. All right, so second one. All right, I need somebody to draw C where it would be placed, and I'll help you out just a little bit. There are your coordinate axes. I need somebody to draw C on the end of B here. All right, you're going to go for it, Cyrus? Now, the only thing you got to make a judgment call on is we didn't put a length on here because he's just estimating. This is now 5.3 centimeters, and how long is C?
4 centimeters.
4 centimeters. So you need to point C in the right direction, and then try your best to make it what you would think would be 4 centimeters. Yeah. Okay. And if you go into them, don't worry about it. Okay. This is a sketch. That's all it is. Oh, hold on. Arrow indicator and label with a letter. And which way does it point? Perfect. All right. All right. Who's going to do H?
Cody.
All right, Cody. Come on up here. All right. So I'm going to kind of erase this temporarily so we can introduce your coordinate axes. Yeah, I will tell you that scale-wise, this is not going to be great. Label it with a letter. But that doesn't matter because what we want to get out from this is some conceptual understanding. Okay, well, I'm going to have more, but we need one more letter, R. I need somebody to put R into this picture for me. Okay, Miriam. Okay. Okay, with an arrow. And we use capitals.
Oh, okay.
Oh, that's, there we go. There we go. Okay. So far so good. I'll get rid of this here. Now I'm going to need 4 more people here. I need somebody to come up here and draw BX and BY. So I need you to take this and draw the X and Y component into the picture. Who thinks they know how that? Okay, David. Go ahead and do a solid. Go ahead and just make it a solid. Okay? And then, okay? And then put arrows on the components the way they point. That's BY. There we go. Okay. And we're going to add a right angle there. Okay? I need somebody to come do that for C. New person. All right, Jake. So, break it into CX and CY. Put arrows, label the X and Y, and then put the right angle. There we go. Okay, perfect. All right, now I need somebody to come do H. Come on. Okay, Barbara. There are actually 2 different ways you could do H. Just do with the one which makes sense to you. Okay, perfect. All right. Right angle there. In other classes, a lot of people have drawn their right triangle like over here because it's away from everything else. This would have been the way that you would have done it like on the sheet, the assignment that I gave you. So I kind of like, this is the first time somebody's done it this way, so I'm kind of like, yes. Okay, one more. I need R broken down. All right, Hunter. And if you're looking at this going, I'm going to go right over the top of something, just run it right on the side of something else so we can see the blue color. Okay, excellent. All right. Now we got the whole thing drawn. I'm going to say, again, on the scale side of things, I don't think it's the greatest. But that doesn't matter, because what we need to do is make some connections from this picture, and we can do that. Now remember, in the end, our goal is to find this, which consists of how long it is, or its magnitude, and the angle that it points at. So, remember that for the black, orange, and green vector, you would have actual numbers for this because you would have been given values for these 3 and you would have broken down what BX and BY are. So think mathematically here. What is Rx, this length here, going to equal?
BX plus CX minus HX.
I'm going to make a correction.
Plus HX. 'cause
Why don't we have to do the minus that you mentioned?
Negative.
Correct.
Two are negative.
So mathematically, this like takes forever. That's what Rx would equal. Now, just so that you can see this graphically, if I were to do this thing graphically, Bx would be a line that would point to the left, and then if I was going to add Cx to it, I would do it tip to tail. So it would continue over here, but then Hx would bring us back to here, which means our Rx would go from here to here, and if you're thinking vector addition, that means it points this way, and that's my Rx. Okay? Guess what that equals? Same thing, except with y. It's by plus cy plus hy. And if you look in the picture, that means we would be drawing bx going up to here, then we would move, or I should say by going vertically, then we would move cy over to here, and then when we move hy to the end of that, it brings us back to here, and then our vector would take us from the beginning of the first one to the end of the last one, and that's our ry. Okay? So the beautiful thing here is you don't have to do any pictures for this, you're just doing math. So now we have Rx and Ry. We want this thing. So the next place I tend to go is here. What part of the picture up here is that? Yeah, just R without the arrow on it. See if somebody remembered this. That it is the hypotenuse of this blue triangle. What did we just figure out about the blue triangle? It's a right triangle. And mathematically, we don't have numbers, but what did we just figure out how to do here? Get Rx and Ry. And I want R.
Rx squared plus Ry.
Algebra 1. Pythagorean formula. So now I got that. Now I need to get that. Now, this is where I don't want you to get lost in the picture, but I want you to think. We got a right triangle. Which sides of the triangle did we figure out? We figured out the two legs of the right triangle. If I told you you have two legs of a right triangle, and I want you to find me an angle associated with that triangle, what are you going to do? You are going to do arctangent. Now, I am just going to give you this because this is the way you always do it. Because sometimes people go, wait, I got to see the picture because I got to know which angle, or I'm just going to tell you the way to do this. And we're going to finish this off on Monday. To get the theta, you are going to do the arctangent, or you are going to need to do the arctangent of always the y piece over the x piece. Okay? So right now, we have the basics of how to do an entire vector problem up here. So now we are going to have to summarize this so that you can remember some nuts and bolts. Step 1. Now, actually, we didn't show you step 1 up here, but you've already done it. before you can do any of this here, what is the first thing you would have to do with all of your vectors?
Draw a picture.
No.
Convert to the component.
Break them into the components. What's the equation that you use? Now, let me rephrase this way. Prove to me you know how to get the x component of a vector in one word.
Cosine.
Cosine. Prove that to me for your vertical component. Sine. So step one, we find Vx, which is V times cosine theta, and Vy, which is V times sine theta. And remember, V is just a generic vector. That's the first step. You had already done that. That's what I asked you to have done by today. Now we come to what we're doing today. What was the next thing that we did? We did some adding. What did we, when we did our adding, what did we come out with? Rx and Ry. See if you guys can somebody summarize this in a very simple mathematical expression? What did we do with all of our x pieces? How do you summarize in a very simple symbol? You add everything together. And what did we add? To get this, all of the x pieces of all of the vectors. Does that make sense? Okay. What's the next thing we did? We did the same thing to get Ry. Now we did that. What was step 3? The Pythagorean theorem, because what did that give us about our vector? The hypotenuse, which is what part of our vector? The magnitude of our vector. Now, I'm not going to write it that way because all we want is r. So I am going to write it that way. Now, when you do the square root, don't be confused with, well, square roots can be positive or negative. We don't do positives or negatives. We always do positives because if we need to do negatives, that just means it points in the opposite direction. We can adjust that with an angle issue. So we're always taking the positive value for this. What's the last thing we did?
The theta with the arctangent.
We did the arctangent. Step 4. Theta equals arctangent Ry over Rx. This is where we're going to have a quick little discussion because we're not completely done there. Plus, and this is what you're going to have to remind me to talk about on Monday. But I'm going to give you a little preview today. This is beautiful math crap. Okay. How many of you, because I can't help but think you, if you've gone far enough in math, this has been thrown out at you. How many of you remember what the problem with arc trigonometric functions are?
It has a range that is only half units.
Very good. Okay. This goes into some very basic math discussion. And for a trigonometric function, I'm just generically going to say, let's look at a sine or cosine thing. Without a coordinate axes, you can't tell whether this is sine or cosine, and it doesn't matter. Is this a function? Yes. Why is it a function?
Passes the vertical line test.
Passes the vertical line test. Yes. Not quite. Does this have an inverse function? Which means, is it 1-to-1? Why not? Because it fails the horizontal line test. Because horizontally speaking, this will cross multiple values. When people started to, develop calculators, first people were like, this is awesome, this machine does math for me. They got to a point where like, hey, let's have it do trig stuff for us. Okay, and people are like, oh, that's awesome. Now, could we have it do regular trig stuff without a problem? Yes, because that's treating it, I call it like y equals, I look at this as y equals a function of x. And I got no problem with that. I can put whatever angle I want into sine, cosine, and I'll get something out. But when they said, let's do the arc functions, now they had a problem. Because that meant instead of thinking of this like this, they had to think of it like this. And because trigonometric functions fail the horizontal line test, that means they got a problem here. Now, to have you think about this, think about, because we're playing with tangent. What's the arctangent of 1? What?
Pi over 4.
Give me degrees.
45.
45. Or, nope,
225.
nope. What? Arctangent 1. Nope.
315, 225.
Oh, unit circle time.
It's in the third quadrant. I don't remember what it is. I don't.
When you say 45,
45.
you're going like that, right? Because you're taking positive 1 over positive 1. But the other place you can get a positive 1 is by having a negative 1 over a negative 1, which is at 225. So when you tell your calculator, I'd like the arctangent of 1, it can't tell you which one. And so people who developed the programming for calculators had to decide, what the hell are we going to do with this? And what they ended up saying was, when we do arc trigonometric functions, we will only give answers that are in the first quadrant or the fourth quadrant. So what if I'm in the third quadrant? Well, you're screwed. You're not really screwed, but you have to realize your calculator is limited. And this is where I love this moment, because people, calculators are so awesome. Calculators are stupid because they can't think. People have to think for the calculator. It can do incredible calculating things for you, but it can't think in a situation like this. So if you wanted to make a smart calculator for this, you would need like an interface. So when you said, I'd like the arctangent of 1, and you hit enter, you would get a question back where it would say, is this arctangent of positive 1 over positive 1, or the arctangent of negative 1 over negative 1? Then it could give you exactly the angle you need. But we don't do that. So that's why we're going to have a discussion about this on Monday. Because this is the one weak spot in the process. This is where you actually have to understand what you're doing. So we will cover that on Monday, though. Any questions? I love this unit. This is like so awesome. Okay, so Monday we'll finish off the picture.